Hey everyone, in this session, let's understand how can we deploy a machine learning model. In all of our previous sessions so far, we have realized how we can develop a well-trained machine learning model to predict either a class for a classification problem and a continuous value for a regression problem. Unless we are exposing the well-trained model in front of the users or clients, the trained machine learning model is of no use. Only developers can use them as a part of Jupyter notebook. But in reality, in order to solve the real world problems, we need to deploy the machine learning model which is well trained so that it will be ready for predictions. In this session, we will understand what is the meaning of deployment of a machine learning model. We will see how can we create a well-trained machine learning model, save it in our secondary memory or in our hard disk, and finally, how can we use those well-trained models in a real-world application. Let's start. Deployment of a machine learning model is a very crucial step to utilize capabilities of machine learning and artificial intelligence in real-world applications. Unless we are deploying a machine learning model, we will not be able to expose the capability of that model for predictions to solve real-world applications. Let's revisit the steps involved in a machine learning project. In a machine learning project, we first understand the problem statement. It can be either regression problem or a classification problem. Once we are well versed with the problem statement, we can start preparing the data. It includes identification, cleaning of the data, encoding of the categorical data. After performing the data preparation, we build the suitable machine learning model. Based on the problem statement, we identify the best suited model and we use data to perform model training. Once we have the trained model, we evaluate the model in form of accuracy, precision, recall and F1 score, etc. If you are not aware about precision, recall and F1 score, I have a dedicated video to perform evaluation of machine learning model in this same playlist. You can watch the same. And finally, when we are satisfied with the performance of our well-trained machine learning model, we are ready to deploy it. That means we can expose the trained model in front of the user so that they can utilize the model and perform predictions. Finally, with the help of logs, we monitor our application and assess the performance time to time to understand if our model needs retraining or not. This is a general flow of any machine learning projects out there. Remember, knowledge is of no value unless you put it into practice. Similarly, your well-trained machine learning model will not deliver any value unless we are deploying it and exposing it for our users. Let's now understand a generic high-level design of any machine learning project. So far, we know how we can create a well-trained machine learning model. But in order to expose this in front of the user, you need some web server. With the help of this web server, we can develop some user interface through which user will communicate with this well-trained model and model will respond back with the predicted value. For user interfaces, we know we have a number of technologies present out there. HTML, CSS are the fundamental technologies used in user interface development. Apart from that, there are very popular UI frameworks available. Angular and React are most popular frameworks for user interface development. When we are speaking about web server, specifically in Python, we have Flask and Django. For models, we have machine learning model, deep learning model, reinforcement learning model. This is the generic high-level design for any machine learning project. We will have UI through which user will interact with our model. We will have web server so that we can host the application and a number of users throughout the world can access our machine learning model, and web server internally uses the trained machine learning model for the prediction. Enough of theory. Let's jump to the Jupyter notebook, where we will first understand how can we develop the trained machine learning model and save it for our future usage. And then we will see how easily, by writing few lines of code with the help of Flask Webserver, we can deploy the web application which uses the trained machine learning model and expose the user interface for users to interact with the trained model. I am in my Jupyter notebook and we will be developing a machine learning model which will predict the diamond price based on the properties of a diamond. Similar to all our previous sessions, we are importing important libraries first. Pandas will be used for data preparation. We will be using xgboost regression model to predict the price of a diamond. If you are not aware about xgboost model, we have a video in the same playlist for the same. You can watch it. We are also importing trend test split method from sklearn in order to split the entire dataset into training data and test data. We will be using sample dataset present in Seaborn, and that's the reason we are importing Seaborn library here. But the main purpose of Seaborn library is for data visualization. If you are not aware about Seaborn library, I have different playlists for data visualization. You can watch the same. Level encoder will be used to convert the categorical values into numeric values. We know joblib helps us to save a well-trained machine learning model. In other words, using joblib library, we can serialize a well-trained machine learning model. Apart from joblib, pickle is also another popular library to save a model. But in this session, let's use joblib. After importing all these important libraries, let's concentrate on the data preparation part, where initially we are importing the sample dataset present in Seaborn library. Let's see what is there within dataset. In this dataset, we have few characteristics or properties of diamond and the corresponding price. Let's ignore X, Y and Z column here. That means our target column or the dependent column will be the price column, because we want to predict the price based on the independent columns or the properties of a diamond. Let's split the entire dataset into feature data frame and target data frame. In feature data frame, we will have caret, cut, color, clarity, depth and table values. These are my independent columns. As you can see, few of our columns are of categorical values. Hence, we have to encode them to get the corresponding numerical values. We are using level encoder for the same. After encoding, the categorical values has been converted into numeric values, which is very important for a machine learning model to consume. Let's create the target data frame with price column. Now it's time to split the entire dataset into training data and test data. We have specified test size as 0.15. That means 15% of the entire dataset will be reserved for testing and 85% of the data will be used for training the model. As it is a regression problem where we are predicting a continuous value which is nothing but the price of the diamond, that's why we need a regressor model. In this session, we are using xgboost regressor. Again, if you are not aware about xgboost model, which is very popular and important model to know for any machine learning engineer or a data scientist, I have a dedicated video for it. Let's use xtrain and ytrain to train the model. Once we have the trained model, let's evaluate the score. Score method takes the test data as its input and gives us the accuracy of our trained model. In this case, the accuracy is 0.98. That means 98% of the time our model will predict the diamond price accurately. Assuming this is the best score what we can get from the model, let's use this model to predict price where the diamond properties are like this. The price is $319. There are a number of ways how you can tune the hyperparameters of a machine learning model in order to enhance the performance of prediction. I highly recommend to watch all my videos in this same playlist so that it will be easy for you to understand how we can perform hyperparameter tuning of a machine learning model. We have already discussed it in our previous sessions. With the help of JobLib, we are serializing the model. In this case, the model is a well-trained model which predicts the diamond price with 98% accuracy. The saved binary file name will be diamond price prediction model. Apart from JobLib, as I have already told, that there are a number of popular libraries out there to save models. Pickle is one of them. Instead of JobLib, you can also use Pickle to save the model. Once we have saved the model as a binary file, we are ready to develop a web application and use this model for predictions. Now I am in my PyCharm IDE where I have created a directory called Flask tutorial. With the help of Flask, we will develop a very simple web application and we will be using diamond price prediction model here. The same binary file what we have created from our Jupyter notebook. We will be exposing this trained model to our users or clients. Apart from the model file, we have two more files. One is index.html, which is nothing but an HTML file what I have created here in order to take the diamond properties from user. This is nothing but the UI in our case, where we are taking caret, cart, color, clarity, depth and table values of a particular diamond. We will have a predict button what user can click on and immediately they will get the predicted price. In that way, we are creating a very simple user interface for our users. Now let's concentrate on app.py file. In this app.py, we are importing Flask. Flask is a very popular Python web server. Using Flask, we can very quickly, by writing few lines of code, we can develop a web application. After importing Flask, we are creating a web application with the help of Flask. We have also imported JobLib because we want to load the same file what we have serialized in our Jupyter notebook. This is converting the binary file what we have saved in our secondary memory and it is loading it into our primary memory with the object name model. And once we load this binary file from secondary memory to our primary memory, we can use this model for our prediction. We don't have to retrain it to perform the predictions. That's the benefit of serializing a well-trained model with the help of JobLib or Pickle. We are creating few APIs using @app.route. Once we go to our web browser and hit the root location, it will execute this home function where we want to show the index.html file what is present within templates folder under Flask tutorial. We have one more route called predict. Predict is a post API which takes the input from users and predict the corresponding price of that diamond and show the price as prediction. As you can see, only this much of code is sufficient to develop a very simple web applications which can run on top of Flask web server. In future, we will have a dedicated session on Flask. But for now, hope you have realized how we are developing a Flask application where we are loading our well-trained model, taking the independent variables from user with the help of a UI and then perform the prediction and finally show it to the user. If you want to run this application, either you can click on this or you can type python space app.py in your terminal, something like this. Once you hit enter, your Flask web server will start running, and your web server will run on 5000 port number of your local computer. If we go to localhost 5000, we get this nice simple HTML form what we have coded in index.html file. We have a number of text boxes through which we are taking the values of all the independent columns, in other words, all the properties of a diamond to predict its price. Here, instead of placing E, we will be put value as 1 because we want numeric values here. If you remember, while training the model, we converted all the categorical values into encoded numerical values with the help of label encoder. Hence, we are providing all the corresponding numeric values for each categorical columns. Once we click on this predict button, it is showing us the predicted price here. In this way, we are exposing the well-trained model what we had created in our Jupyter notebook so that any user can use our web application to predict the diamond price based on few properties of a diamond. Now, for UI development, you can use any popular frameworks like React or Angular to enhance the user experience. But here, I wanted to show you the bare minimum setup through which we can deploy a machine learning model and expose it for predictions through a web application. Let's check out the takeaways from this session. In this session, we realized how can we deploy a machine learning model so that we can develop web application on top of it and utilize the capabilities of machine learning or artificial intelligence in order to solve real world applications. Now we know the important steps for each and every machine learning projects out there. Till model evaluation and validation we have seen in our previous sessions. In this session, we specially discussed about the model deployment, and finally using Jupyter Notebook we have developed a trained machine learning model for diamond price prediction, and with the help of Flask application we exposed it to the users so that they can easily predict the diamond price based on the diamond properties. We developed a very simple HTML page through which we are taking all the inputs from user and finally showing the predicted price for that particular diamond. Hope now you have realized the bare minimum requirement to deploy a machine learning model to expose the capabilities of artificial intelligence. Hope you have enjoyed this session. Thanks a lot for watching this video.